Welcome everybody, it's Ramachandra from CIVIL-MECH-MATHS concepts. Today I have released third lecture on structural analysis, will be useful for both GATE and SSC JE aspirants, and in this I have resolved the forces in the members and also classified them either as tension and compression, and the total process is explained and 2 members were left for a homework to all of you. Best of luck. Welcome everybody, it's Ramachandra from CIVIL-MECH-MATHS concepts. Again, we will be solving the pin jointed truss. Again in this lecture, I continued with the pin jointed structure truss solution. In the first class, it is the structural analysis, lecture number 3. In the first class, we have given some definitions and introduction. In the second lecture, we have solved for reaction forces, and in the third lecture, we will be going for member forces, identifying compression and tension. First, let us see whether this is a perfect truss or not. In the last class, we have checked what is the rule for perfect frame. It is number of members should be equal to 2 into number of joints minus 3. How many joints are there in this truss? There are 7 joints. 2 into 7 is 14. Minus 3 is equal to 11. How many members are there? There are 11 members in the truss. There are 11 members. What are the members? This is 1. Member number 1, member number 2, member number 3, because whatever we have started from the beginning, same we have to repeat here. We can't change in between. It is number 5 member, and it is number 7, it is number 9. These are numbers of the members. We have to find forces in all the members, and we have to find whether they are under tension, compressive forces, or whether they are tensile forces. The frame is perfect because m is equal to 2j minus 3 rule. It is accepting. Hence, frame is a perfect frame. Hence, we can resolve this frame, and we have found out the reaction forces. And we have had a concept about how to find out the movement about a particular point by a force. Now, let's go. We have 3 equilibrium equations. At a particular joint, we are going as per the method of joints. There are 2 types of methods, as I told you in the last lecture. One is method of joints, another is method of sections. Here we are applying method of joints. Method of sections, when I take up the full class on trusses, this is only introductory class to know how to solve the forces, because it is one of the major issues. People make mistakes in minus and plus, end up in some different answer. That should not happen. You should understand the concept. For that only, this pressure, this force analysis, movement analysis, I am doing it very carefully so that your concepts will be clear and you will do better in the examinations and even in day-to-day working also. Now, we will go with method of joints. This is an introductory class for structural analysis. In the next class onwards, we will be going for beams, designs, RCC, steel designs, and all those things. They are all major topics. This is an introductory class to know about forces and movements. And structural analysis cannot be taught by theory. It is not a theory. We have to solve the problems, then only we can understand what is structural analysis. Hence only I started with a problem. I started solving the problem so that you will get the concepts along with the problem solution. You cannot read the concepts and go and sit in an examination. In structural analysis, especially strength of material, structural analysis, the problem solving and learning the concepts both go together. That is my intention. Again, it's Ramchandra from CIVIL-MECH-MATHS Concepts. Welcome everybody. We'll start the class. Now, the first thing is that we have to understand what is compression and what is tension in a member. In a member, any force towards the joint is the compression, and any force away from the joint is tension. Now, we will do like this. First, we will take up the joint 1 so that you will understand what is what. We will take up joint 1. There is a horizontal force also we have resolved yesterday in the last class, that is R1x, that is equal to 0. Now, we will write here joint 1. Please very careful. If it is slow also, don't mind. Don't be in a hurry to solve any problem. Try to understand the concept. If you do it with yourself along with me, then you will try understand the concepts very well, and you need not do 100 problems. Do one problem, but do it perfectly to clear your concepts. This is the joint 1. What are the forces acting on it? One is R1y, that is equal to 39 kilonewtons, and another force R1x, that is equal to 0. Yesterday we have found. And always remember this, for the unknown forces, always think that it is tension. For unknown forces, always think that it is tension. Then, if you get a negative answer, you can afterwards change the direction and say that it is compression. But by judging the frame, judging the structure, never assume that something is compression and something is tension. It will land you in problem. First, always think the unknown force as tension. What is the unknown force here? The force in the member 1 to 2. The force in the member jointing 1 to 2. I have treated this as the tensile force. This is unknown to me. And another force, the joint is having another member also, member 2, that is from 1 to 3. It is also unknown. What our equilibrium equations say? Please follow carefully. Equilibrium implies sigma fx is equal to 0 and sigma fy is equal to 0. Don't bother about any sign convention. First apply this formula, that's all. Sum of the forces acting in the x direction R1x and F13 both are acting in the same direction. Hence they have to be added. R1x plus F13 is equal to 0. That implies, but R1x is already 0. 0 plus F13 is equal to 0. That means F13 is equal to 0. This unknown is found out 0 kilonewtons. That is the member joints 1 and 3 is a member without force. That is a no tension, no compression member. This is one of the major questions will be asked in SSC JE or UPSC or GATE. This question is, which of the members in the truss are with zero member force or null member force? That means answer is F13 is null force. There is no force. A member with no force is F13 answer. Next comes, you just see how concepts are being developed. Sigma Fy is equal to 0. That implies Fy, don't worry about the sign convention, as I told you. R1y and F12 both are acting in the same direction. What is the sigma? They are addition. That means R1y plus F12 is equal to 0. That means F12 is equal to minus R1y. That is equal to, what is R1y? That is 39 minus 39. That means whatever we have assumed the direction, that direction is wrong, and the new direction will be, new FBD will be, this is initially assumed. Final FBD for the joint will be, what is the final FBD? This is the joint 1. This is 39 kilonewtons. This is 0 kilonewtons. This is 0 kilonewtons. And this is 39 kilonewtons. You please see. Once we change the direction of the force, minus sign goes off. This is what the final FBD. Now, we will go to joint 2. In a member, please remember, in a member, it is also very important concept. Whether it is written in the books or not, I don't know, but this way I go and I get the correct answers. Very important concept. If there is a member is like this, some force is this way, there is other side, other joint force will be this side. Why this is? This is very important concept. If this is of, I say F1, this is F2. If F1 and F2 are not in equilibrium, what happens? The member itself gets distorted. As within the member, for it to be in equilibrium, this is the direction of the force F1 towards the joint. Here is the joint. Here is the joint. F2 also should be towards the joint. This you please remember. This is compression. This is also compression. One joint and another joint within the member. Within the member. Without the external force influence. They cannot have two forces. One is compression and one is tension. This within the member, same member, for equilibrium, if something is towards the joint is F1, the same thing will be towards the joint on the other end, and F2 and F1 both will be of same nature and same quantity. That is within the member. Now, why I told you, in the next joint you will understand. This is very important. Next joint is joint 2. I am going one by one so that your concepts should be clear. Here only problem comes. It is not about the values, it is about the concept. This is my second joint. In the second joint, one member is connecting 1 and 2, another member is connecting 2 and 3, another member is connecting 2 and 4. There are 3 members, and one force is downwards 15 kilonewtons. And what about this 1 and 2? F1, 2 we have found out. The direction also we have found out. Now let us apply our concept. Now you apply your concept. Don't bog down by minus plus minus plus. Because what happens, an error may cause confusion and errors in the examination. A simple error somewhere will make your forces imbalanced in the truss. Not only in the examination, in day-to-day life also. Member 2. This member has one towards 1, the joint towards 4, this is F2, 4. I am always thinking it is tension. And here in this number, here it is F12 is equal to 39 kilonewtons compression. Either you write minus 39 kilonewtons or you write 39 kilonewtons compression with a sign convention stating clearly that tension is equal to positive, compression is equal to negative. You can remove the sign. Now, it is compression means what it is towards the joint. Compression, I have told in the beginning itself, compression is towards the joint. Away from the joint is tension. Now towards the joint. That means, if in the same member, F1 is compression means F2 cannot be tension. F2 should be compression. Same member without the external forces influence. Free body diagram when you write, this should be compression towards the center. That is F12. Towards the joint. And another is 15 kilonewtons. This is what is the force applied, external force. Another is You see the directions. F 2 3 at an angle of 30 degrees. Now we have got everything at the joint 2. Now sigma fx is equal to 0 and sigma fy is equal to 0. Let us apply. What happens? Let us see. This is what we have to find out. This is what we have to find out, unknown. Now, when F23 moves towards the x-axis, 30 degrees, when it is near to the y-axis, it is sin 30. Near to the y-axis is cos 30, away from the y-axis is sin 30. Now, you please see what it will be. Sigma fx, let us say. Components I have already explained you. In the first class, I have already explained the concepts. Components F24 is directly acting in this direction, F24, and F23 component is also acting in the same direction, that is F23 into sin 30, because it is away. Both are acting in the same direction. Is equal to 0. That means F24 plus 0.5 F23 is equal to 0. That is the equation 1. Sin 30 is equal to 0.5. Please remember these values. Now, we have to find the second equation. What is the second equation? In y direction, just directions only you take. Don't worry about minus plus. Sum of the upward forces. In this direction, it will be F23 cos 30. What are the upward direction forces? Is F12 is equal to downward direction forces 15 kilonewtons plus F23 cos 30. Upward is equal to downward. That's all. That's what I have told you. F upward is equal to F downward. This is the meaning of sigma Fi is equal to 0. Then, what will be the value of F12? F12 is nothing but, what is the value of F12? We are only taking here directions. F12 is 39 kilonewtons. It is 39 kilonewtons is acting upwards. Please try to understand. I am not putting any minus plus. I am only analyzing the joint. From the beginning, I am not confusing myself and everybody with signs. Compression means it is towards the joint. Tension means away from the joint. Sigma Fi is equal to 0 means sum of the upward forces is equal to sum of the downward forces at the joint. Sum of the left hand side forces is equal to sum of the right hand side forces. That is in the x direction. I am taking a 2D truss only, resolving the forces in the x direction and y direction only. Please try to understand this concept. Now, F12 is 39 kilonewtons. It is at the joint 2. Its direction is towards the joint and upwards. F12 is that upward force is equal to total downward force. What is the downward force? 15 kilonewtons plus F23 is not known to us. F23 into cos 60 is 0.866. That means F23 is equal to 39 minus 15 divided by cos 30. That is equal to 24 divided by 0.866. Check the answer. What it will be? (24 divided by cos 30). 27.713. 7. Let us take 2 digits. F23 is, and whatever direction we have found for F23, need not be changed because the value has come positive. That means the value did not change the sign. Hence, the direction assumed by us is valid. That means this is tension. F23 is equal to 27.71 kilonewtons tension. This is the value. Now another, what is that we have to find out? Next, F24. F24 is also there. We have to find out F24. What is from equation 2? Equation 1. F24 plus 0.5 F23 is equal to 0. That implies F24 is equal to minus 0.5 into F23. That is equal to minus 0.5 into, what is F23? 27.71. (27.71 into 0.5), 13.85. We are taking only up to 2 digits. This is minus. That means F24 is equal to 13.85 kilonewtons in magnitude, and it is compression. It is towards the joint. Hence, whatever for F24 we have assumed, that is wrong. It should act in this direction. Because it is compression, it should be towards the joint. Then what is the final shape of the free body diagram? This is like this. This is 13.85. This is 39. This is 27.71, and this is 15. This is what is the final answer we have got for the. In the examination, they may give a truss. They may not ask you to analyze the full truss. They may give the free body diagram for the joint number 2. Like that they may ask the question. And they may give the alternatives, different alternatives. Joint 2 they will take, 15 they will put as downwards, 39 they will put as upwards, so that it is known to everybody. Next, they will put 13.85 away from the joint, 27.71 towards the joint, away, towards, away, they will make. And ask you to find out the correct alternative of the free body diagram from this. This free body diagram never talks about the negative positive signs which we assume. It only talks about at a particular joint whether force is acting towards the joint or away from the joint. Nomenclature is given by us, not by the force. Force is acting in this direction. That's all. The direction you assume it as positive or negative, that is up to you. We follow certain norms and we are following. That is the convention. That convention is not rigid. In research, conventions can change. They need not be rigid. Now, I think you might have understood. Now, I will do it for another member. Which member we will take now? You tell me. Reactions are completed. This is number 2 is completed. Shall we go for? Because one by one we have to go. We can't jump into some point and we will say that this is possible. Because until and unless you get something in a sequential manner, you cannot answer this problem. Now joint 1 is over, joint 2 is over. Now we will go for joint 4. Because in joint 4 what is there? We don't know 4 to 5. We know about 2 to 4 force and we know about 2 to 3 force. So that 2 forces are known, 2 forces unknown, we can find out. We have to see that also. How many forces are unknown? Now, let us take the joint 4. It's a lengthy problem, but however, go slow and understand. Don't jump. We should never make mistakes. Mistakes are not, they will cost us. The alternatives are chosen in such a way so that mistakes also look like correct ones. This is 10 kilonewtons. We are talking about the joint number 4 here. Ten kilonewtons is upward force, and we don't know about force 4 to 5. Force 4 to 5. This we will treat it as tension, because I told you in the beginning, any unknown force should be treated away from the joint and should be treated as tension away from the joint. And another force is also unknown to us. This is joining 4 and 3, that is 3, 4 we can say, 4 and 3, because we are not using the sign conventions. No problem, we can say. This is also unknown. And this force What is that force? At the joint for force 224, F24. What is that F24 we have found? It is as a compression. Compression means towards the joint, 13.85. Please listen to me. This is towards the joint, 13.85 kilonewtons. I think this is the free body diagram. Now, from FDB, sigma Fx is equal to 0. Apply this formula. Sigma Fy is equal to 0. Sigma Fx. Sigma Fx is equal to 0 means the F24 and F45 with the directions we have assumed they are acting in the same direction and there are no forces acting in the opposite direction. Hence, F24 plus F45 is equal to 0. The directions towards the right hand side. Here we can be rather very clear. Like upward is equal to downward. Similarly, right hand direction or x positive direction forces is equal to forces towards left hand direction or x negative direction. Now you just see F positive direction, what are there? F24 plus F45, this is the assumed direction, is equal to, in the left direction there are no forces. That implies F24 plus F45 is equal to 0. That means F45 is equal to minus F24. What is the F24 value? Numerical value is 13.85. That means it will be minus 13.85 kilonewtons. If it is minus means our assumed direction is wrong, correct direction is like this. This is nothing but 13.85 kilonewtons compression. That means this member is under compression. A member joining the joints 4 and 5 is under compression and its value is 13.85 kilonewtons. This is the answer. In questions, some questions may be asked. How many members in the truss are under compression? How many members in the truss are under tension? And they may ask a particular member whether it is in tension or compression. Any type of question can be asked. Further to I am elaborating so that you should understand the concept clear. Now, this is sigma Fx is over. Now sigma Fy is equal to 0 implies. What does it imply? What are the forces acting downward? Sigma F downward is equal to sigma F upward. Means downward is 10 plus F34. Upward is 0. There is no force acting upward. That means F34 is equal to minus 10 kilonewtons. That is equal to 10 kilonewtons compression. That means whatever direction we have assumed, that direction is wrong and the direction of it will be, correct direction will be this, and this value is 10 kilonewtons. The magnitude is towards the joint, and magnitude is 10 kilonewtons, direction is towards the joint. What is the final FBD? Final FBD is, this is the joint for F45, that is equal to 13.85, rather we will write not F45 and all those, 13.85 kilonewtons, and this is 10 kilonewtons, and this is 10 kilonewtons, and F24 is 13.85. This is the final FBD. Here we are not putting any signs, we are only interested in at the joint whether the force is compressive force or a tensile force. Why I am teaching this way? If you go this way, tension, compression, giving a undisputed definitions, it will help you while we are going forward toward the structural analysis of beams, slabs, and different types of structures, arches, bridges. There are many structures in which this type of understanding of the concept is going to help you. Now, this is also compression, F45, and F34 is also compression. Now let's go for another member. Which member shall we go? We have completed this also. We will make a round. Now, the most complicated member in the structure is this one. Shall we go for it? Maximum number of forces. Now, joint F3. Joint 3, not F3, rather it is joint 3. What is at joint 3? We have forces. This is the joint 3. One force is 3 to 6, that is unknown. Unknown force will be, we will be treating it as away from the joint. This is unknown, we have to find out. And one force is downwards, 21 kilonewtons. We are only talking about the joint. In this joint, and another force is force 3, 4. We have to see the direction. What is the direction of 3, 4? It is towards the joint 10 kilonewtons. This is towards the joint 10 kilonewtons. This is F34. Now, another force is acting that is F23 at an angle. What is the force F23? F23 is 27.71 tension away from the joint. This is away from the joint. F23 27.71. Now another force is also there. F35. Another force is there. Did we find out F35 any time? No, I didn't think so. F35 is unknown. This unknown, let it be away from the joint. And angles, let us put for the inclined forces. This angle is 60 degrees. This angle is 60 degrees. And another force is also there at joint. F23. What is the value of F23? Not F23, F13. What is the value of F13? F13 is 0. This is the member which is with 0. You assume any direction, no problem. F13 is equal to 0. That means how many members are there at this joint? 1, 2, 3, 4, 5 members. There should be 5 forces. You just see, this is the joint 3. At the joint 3, one member is connecting joint 1 and 3. That is equal to 0 value. Another is connecting 2 and 3 at an angle 60 degrees. That is F23. Again we will cross check here. F23 is tension away from the joint to 27.71 at an angle 60 degrees. Another is F34. F34 is compression towards the joint 10 kilonewtons. And another is F35 at an angle of 60 degrees, that is unknown. That we treated it as tension away from the joint. And F36 is unknown away from the joint. We have to find out F35 and F36. Find out F35 and F36. Now another external force is also acting at the joint, that is 21 kilonewtons downwards. Now let us say sigma Fx is equal to 0. Sigma Fx is equal to 0 means the 60 degrees when F23 x component means that is near to the angle, that should be F23 cos 60. This is this way, and this way F35 cos 60, and this way F35 sin 60. We are resolving the forces in all the directions. And this way F23 cos 60. Now let's go for it. Sigma Fx. What are the forces acting in the left hand direction? Left hand direction forces are 0. 1 is there. That means left hand side forces F23 cos 60 is equal to right hand side forces. What are the right hand side forces? F35 cos 60 plus f36 from the assumed directions. This is equation 1. Then one way go for sigma Fi is equal to 0. It implies upward is equal to downward. What are the upward forces? F23 cos 60 plus F35 sin 60, upward forces. That's all. These two are the upward forces. Is equal to downward forces 10 kilonewtons plus 21 kilonewtons. These are the downward forces. This is equation 2. From these two equations, two unknowns, two equations, we can solve the problem. Now, we will go for the equation number 2. What is F23? 27.71 into what is cos 60? Cos 60 is 0.5 plus what is F35? F35 is unknown. What is sin 60? 0.866 is equal to 31. That implies F35 is equal to, you do this mathematics, 31 minus 0.5 into 27.71 divided by cos 60. What is the value? Not sin, it is sin 60. Sorry. 31 minus 0.5 into 27.71 whole divided by sin 60. Are we getting the correct values? 21 plus 10 is 31. Just check up. Then F35 is equal to F23 into cos 60. F23 is 27.71 into cos 60. That is for sigma fx. F23 into cos 60 is equal to F35 into cos 60 plus F36. That is perfect. Next for Fys, F23 into, it is sin 60, it is not cos 60. There is a problem. That's what I am checking. Because Y direction, when it is going in this direction, it should be sine. It cannot be cos, away from angle. Sine 60. Which implies f23 into sine 60 plus f35 into sine 60 is equal to 31. Then f35 is equal to 27.71 into sine 60, 31 minus 27.71 into sine 60 divided by whole divided by sine 60. That implies f35 is equal to 31 minus 27.71 into sine 60 whole divided by sine 60. That is equal to 8.085. And we will say only 2 digits we will be taking from the beginning. 8.08 kilonewtons. It has not changed. Its value is positive. That means the whatever direction we have assumed is the correct direction for F35. This is the value we got. Hence, it is tension. F35 is 8.08 kilonewtons tension. Now, we have to find out from the equation 1 F36. What is the equation? F23 into cos 60 is equal to F35 is 8.08 into cos 60 plus F36, which implies F36 is equal to F23. What is the value? 27.71 into cos 60 is 0.5 minus 8.08 into cos 60. That is equal to 9.815. This is also value has come as positive, hence it is tension. Whatever direction we have assumed is correct. This is the value for 2 unknown forces at the joint 3. Now, finally, we will draw the final free body diagram. This is joint 3. At this, F35 is acting away from the joint. That is tension 8.08. F36 tension away from the joint 9.815. External force away from the joint, it is tension 21 kilonewtons. It is external, it is not tension, it is downwards. And F13, because it is dummy 0, then direction doesn't matter. And external for the member F34 towards the joint F34 value is 10 kilonewtons, and F23 away from the joint 27.71. This is the final free body diagram for the joint. 3. Anywhere if you make a small mistake also, these values will be turned negative to positive. Forget about the magnitude, even directions will change. We should be very very careful in putting sin theta, cos theta, and near to the angle is cos theta, away from the angle is sin theta. We should not make the problems. Now, I feel with this I will stop today's class. About 75% of the member forces I have calculated, and you are left with member 9, member 10 and member 11. I hope with these concepts you will be able to solve these three members 9, 10 and 11. Please solve them as a homework. Please do as a homework. Today's homework is solve for the forces in the remaining members of the truss. Mark them on free body diagram as tension or compression. Now, the final understanding from this initial class of resolving a simple pin joint truss without indeterminacy, it's a perfect truss, it is not an imperfect truss. We understood that if the number of members required for a truss to be perfect, M is equal to, number of members is equal to twice the number of joints minus 3. This is one takeaway, important takeaway. This implies perfect frame. Second is towards the joint, we treated it as compression in the member. Third is away from the joint, we treated as tension in the member. Fourth, if the final value comes as negative, it implies that our assumed direction of force to be reversed. Before this, most important, fifth is always assume force as tension and solve the problem. Next takeaway, sigma fx is equal to 0 implies sigma f right hand, in the right hand direction forces acting is equal to sigma f left hand direction. 7. Sigma fy is equal to 0 implies sigma f downward is equal to sigma f upward. Please remember these steps. And final, last and most important, movement about a point joint implies sigma m at a point P is equal to 0. The net moment. These are the 8-9 points we have to remember and solve the problems. Solve for the remaining forces. Then in the next class we will be starting most important topic, strength of materials. We can call it as strength of materials. Some people call it as mechanics of materials. Some may say solid mechanics, or we can say rather that beam theory, beams, all these things we will discuss from next class onwards. Best of luck to everybody. It's Ramchandra from CIVIL-MECH-MATHS concepts. If you like my video, please view the other videos also, review them and comment on them so that I will respond to your comments. Next is, for the benefit of all your friends and colleagues also, you please circulate these videos and try to subscribe. Kindly subscribe to my videos, my channel, so that you will get regular updates on my videos. Please view, review, comment and subscribe. View all my videos. I have made playlists as my playlists are Civil Engineering, SSC JE, Civil Engineering, GATE, Mechanical Engineering, SSC JE, GATE, Engineering, Mathematics. I will provide links to all of these. I will provide the links to all of these playlists in the description below my video. Please view, review, comment on my other videos also and see these videos, repeat these videos and try to understand the concepts and do better in the examination. Best of luck to everybody. There are about 46 videos till now from my channel published and released. Best of luck to everybody. It's Ramachandra from CIVIL-MECH-MATHS Concepts. Thank you for listening to me.